Alright, so we're going to start having a look at differentiating ln. A couple of things to remember before you start differentiating ln. So ln, just to remind yourself, is the same as the log base e. So a couple of things that can make your life easier is to remember the laws of logs. So for instance, if you have ln of p over q, that's ln of p minus ln of q. And this is without doing any differentiation, so we are not differentiating at the moment. Second law to remember when we're doing logs is that the ln of p will say to the power of n, so p to some power. You can bring the power out the front, so you get n times ln of p. And this is not differentiating, so it's important to remember we are not differentiating when we do this. We're not differentiating, we're simply using the laws of logs. So we're going to use these to simplify things before we start differentiating. So we still have y equals because we haven't got dy dx yet. So it's ln of a top line over a bottom line. So from the first of these laws here, that's ln of the top line, square root of 16 minus x squared, minus ln of the bottom line, 4 plus x. Alright, now this square root we don't particularly like. It would be nice if we could get rid of it. So again, before we even start differentiating, we're going to write that square root as a power. Now what we're going to do next looks very like differentiation, but it isn't, and it's important that you keep the difference straight in your head. We're going to use the second law here. The second law here says that ln of something to a power, that when you have a power in here, you can bring the power out the front, and that this is the same as this. These are the same. We're not differentiating, we still have y. We haven't got dy dx yet. It looks like differentiation, but it's important to keep in mind, or to kind of always remember that it is not different. We haven't differentiated yet. This is not differentiation. This is using the laws of logs to take a power and put it out the front. And now we are going to differentiate. So now dy dx, we have a half, so we leave the half out the front. And if you remember, when you differentiate ln of x, you get 1 over x. So when we differentiate ln of something, we should first of all get 1 over that something. And if you remember your chain rule, then what we need to do is we need to multiply by. So we've ln of something, differentiate can be 1 over something, multiplied by the derivative of this thing. Alright, so when you differentiate 16, we get nothing. When we differentiate this, we get minus 2x. So the half stays out the front. ln of something gives me 1 over that something. And then we need to cover the ln and differentiate what's inside the bracket. So we differentiate 16 minus x squared and we get minus 2x. Okay, for the second one, we'll leave the minus out the front. We have ln of something, so we get 1 over that something. So 1 over 4 plus x. And we need to multiply it by the derivative of what's in here. So multiply it by the derivative of 4 plus x. So that's just 1. Derivative of 4 is 0. Derivative of x is 1. Alright, so looking at this now, we have this 2 on the top line. This 2 we can divide top and bottom by 2. So we have minus x on the top line over 16 minus x squared minus 1 over 4 plus x. Okay, now there's a little bit of simplifying we can do. So to simplify this, we'd spot that the bottom line there is actually the difference of 2 squares. And not alone is it the difference of 2 squares, so 4 minus x by 4 plus x. One of those squares is the same as the bottom line over here. So our common denominator, when we're going to go add these two things, our common denominator is going to be 4 minus x into 4 plus x. Alright, so we have finished the differentiation. The differentiation took place up here, differentiation is done. This is now seeing can we finish off, do a bit of algebra. Alright, so the common denominator, it's important that you remember this is not an equation. It's not a left hand side equals a right hand side. We're working out what dy dx is. We're working out what this value is. So I can't just multiply that by something just because I don't like the bottom lines. So what I do instead is I put each thing over the common denominator. So I don't have to change this one. This one here, I already have a 4 plus x. So if I want to make the common denominator, I've got to multiply that 4 plus x by 4 minus x. Now if I multiply the bottom by 4 minus x, in order to keep the fraction the same, I have to multiply the top by 4 minus x. So we end up with minus x, 4 minus x times 4 plus x. So we have minus x here. Now this minus needs to be multiplied into the top line. So it's got to be, get rid of him. This is a minus by 1 times whatever's in the bracket. So you got to multiply the minus by the 4, and you got to multiply the minus by the minus x. So you'll now put minus by 4 gives me minus 4. Minus by minus x gives me plus x. So I actually end up with minus 4 on the top line, and if you want to multiply that back out, that's 16 minus x squared on the bottom. So that and that cancelled. If you multiply this back out, you get 4 by 4 is 16, 4 by x is 4x, minus x by 4 is minus 4x, so they'll cancel minus x by. Anyway, you know that from back up here, you can see that this and this are the same. This came from factorizing this thing, so you can write it like this, or you can write it like this. The only reason I'm writing it that way is that if you take a look at question 11c that you had, that's the kind of form that you're asked for the answer in question 11c. Alright, so these laws up here, just to run back over very quickly, these laws up here, these are the laws of logs. I have not differentiated when I use these laws. It's important to remember that. This is not differentiating. This is just rewriting it in a simpler form. So I use them to take my fraction and break up my fraction, top line minus ln at the bottom. I write the square root as the power of a half, and then I bring that down the front. This is as simple as I can make the thing, so now I differentiate it. When I differentiate ln of something, I get 1 over that something, and I have to multiply by the derivative of what's in the bracket. So that there is the derivative of that. Over here, I differentiate to get 1 over 4 plus x, and then I have to multiply by the derivative of what's in the bracket. Okay, so you do a little bit of tidying. You look for a common denominator. You could multiply them together to get the common denominator, but that makes your life a lot more difficult than it needs to be. You need to spot that this is the difference of two squares, then get your common denominator. Be careful with the minus sign, and everything works out the way that it's meant to.